Okay, so we talked about solving equations a chapter or so ago, but we got to at the end of that chapter. We did inequalities. We solved some inequalities. Same thing here. We've been doing some linear equations. We need to do linear inequalities, two variables. Linear inequalities in two variables. Well, let me just show you one. X minus y is less than or equal to 2. Turns out this is similar to our linear equations that we had previously. It's similar because, well, it's x to the first, y to the first, and then a number over there. So this is kind of like standard form, but we have an inequality in the mix there as well. Instead of an equal to, we have less than or equal to. All right, well, turns out what this means, and I'll just show you the graph here, and we'll talk about how to get it in a second, but turns out it goes through 2 there and negative 2 right there. There's our line. It still has a line involved, so we're still going to be graphing some lines, but then we also have shading. Turns out the inequality part, what that adds to it is a lot more points, in that what we're saying here is any point, instead of just being points on the line work, but any point above the line also works in that inequality. You know, 0, 0 works, it's not on the line, 1, 1, 2, 5, all these points and all these points down here, anything above that line works. So that's what the inequality part adds to it. It adds, you got a line, but then you have the shading as well. So that's what these graphs of these lines will wind up looking like. Okay? All right. So let's talk about how we go through that process and graph one of these. Has everybody got that one? I need a lot of board space. So okay, take this one. All right, so let's graph x plus 2y is less than or equal to 4. X plus 2y is less than or equal to your 4. Okay, really, I like to say there's 2 steps. There's graphing the line step. Then there's step 2 is going to be the shading, because that's what we saw. We saw that previous one we had a line, then we had the shading. So that's our 2 steps. We're going to graph the line, and then we're going to do the shading and talk about that. All right. So the line part of this is just the x plus 2y equals 4 part. And you know, to graph that line, like we said, we now know several ways. We know table. You can do a table. You can do the x and y intercepts. You can even, you could even get it to y equals mx plus b if you wanted to, and do it that way. This way, pretty easy to just do the intercept. So that's the way I usually do these. Get the x-intercept and the y-intercept, and that'll be our 2 points, and then we can graph it. So the x-intercept, and it's, again, good review here. The x-intercept, we always set the y to 0, right? So that's going to be a nice little equation, because that would just be x equals 4. 4, 0 is going to be my x-intercept, then my y-intercept. Do the reverse of that, right? Set x to be 0. Here, 0 plus 2y equals 4. So that would be 2y equals 4 divided by 2. So y is 2 in the y-intercept, so the y-intercept 0, 2. So that gives me enough information to graph my line. 4 zeros, 0, 2. What did I say? 4, 0, right there. 0, 2 is right there. There's my line. Okay? All right. But yeah, that just takes care of the line part. As we know, the inequality adds to this some shading. So step 2, what about the shading? Well, I guess we could flip a coin and say, well, I could either shade above it or below it, flip a coin, see which to do, but that may or may not be correct. Got a 50-50 shot if you do it that way. But here's a more direct way of doing it. Really, it can come down to just one point, because if I know what happens at one of the points, if one of the points that's not on the line works, then wouldn't it stand to reason that all the points on that same side would have to go with it? Because if I'm going to shade, this point, then I'd have to shade everything. All right, so really it's just check a point not on the line. That's what we're going to do. Check a point, and we're going back to the inequality now. We're going to check a point not on the line to see if it works in that inequality. Now, a good point here to check would be 0, 0 for obvious reasons. The x is 0, the y is 0, right? 0, 0 is not on the line, so I'm going to check 0, 0 to see if it works. All right, so to 0, x, 0, y, if I plug that in, going back to this now, if I plug in the x is 0, the y is 0, does that work? It's not very good. 0, all right. So if I plug in x to be 0, y to be 0, is that a true inequality? Because sometimes it turn out it won't be a true inequality. But in this case, we've got 0 plus 0, which is 0, is less than or equal to 4, which is true. That tells me 0, 0 is working, right? So that tells me I better up here on the shading shade the side that has 0, 0 on it, right? Which in this case it happens to be below the line, right? Here's 0, 0, so 0, 0 is below the line, so I'd shade below to capture the 0, 0 and then all the other points. If 0, 0 hadn't worked, then I'd have to go to the other side, right? Because I know that point doesn't work, so neither do any of the points. But in this case, 0, 0 works. And you can check some others if you want, but all the other points below this line will satisfy the inequality, because that one did, they all do. Okay? So that's the process there. All right. How about then another one? 3x minus 2y is greater than or equal to 6. All right, so the first step is do the line. So 3x minus 2y equals 6. Said you can do it however you want. I tend to do the intercepts. The intercepts set for the x-intercept set y equal to 0. That's 0, so that's 3x equals 6. Divide by 3. My x equals 2, so my x-intercept is 2, 0. Then get the y-intercept. Reverse that. Set x equal to 0. So that'd be 3 times 0 minus 2y equals 6. So that's 0 there. So that'd be minus 2y equals 6. Write off the negative 2, and that's y equals negative 3. So the y-intercept is 0, negative 3. With me on that? Okay. 2, 0, 0, negative 3. There's my line. Okay? But we know with an inequality, there's more to it, and there is shading involved. And so how do we determine which side to go with? Without just taking a stab in the dark. Well, we check a point. Check a point not on the line. And 0, 0, go with it if you can, because for obvious reasons. You don't have to do that, but 0, 0 is not on the line. That may be the one you want to check. All right, so the 0, 0 works. So we got 3 times 0 minus 2y, y 0. Is that greater than or equal to 6? That's 0, 0, greater than or equal to 6. Is that true? 0 is greater than 6? No. Not true. What is that telling you? I don't want to shade to get the 0, 0 involved, do I? So I want to shade. 0, 0 doesn't work. So I don't want to shade it where 0, 0 would be included. So I go to the other side, right? Shade the side that doesn't have 0, 0. Here's 0, 0, which is on this side, so I'd go to the other side. How's that? Okay? So in inequality, you just do the line, but then you do the shading as well. All right? Okay. Now, while I have this one up here, let me talk about one that would be very much related. What if I changed my inequality there and instead of greater than or equal to, let's say it was just greater than. How would that change things up? Let's talk about it. Well, what is different about that? Just one little thing, right? This is greater than or equal to, that's strictly greater than. I don't have equal to, okay? It doesn't have equal to. Now, what you have to understand here, so there's no equal to there. What you have to understand about this is when I graph this, I graph the line, but the reason I included the line, made it a solid line, was because the equal to part was involved. Isn't the line the equal to part? The line is the equal to part, isn't it? The shading is the greater than part. That's what it amounts to. The line is the equal to part, the shading is the greater than. Since this doesn't have the equal to part, guess what, technically speaking, is not involved? The line. So the line is still a boundary line, but it's not technically included in that solution set. So what do I change? Well, I still have the same x and y intercepts. I still have the line. It's just going to be a boundary line, though. It's not going to be, in other words, a solid line. And so to designate that, I'm going to put it in as a dotted line. If you don't have the equal to part, your line is going to be a dotted line. So if it's strictly greater than or strictly less than, use a dotted line instead. So if you don't have the equal to part in the inequality, use a dotted line. So that would change. Now, I still have shading, right, because I still have the inequality there. So it's still shaded, and if you think about it, 0, 0 is still not going to work, so it's still going to be shaded this way. So everything's the same except that it's a dotted line instead of a solid line. Okay? So keep that in mind when you're doing these. I got one more here to show you. y is less than negative 3x. Y less than negative 3x. Okay? All right, so it's an inequality. We're graphing it. So there's two parts. Graph the line first. The y equals negative 3x. Just graph its line. Okay, well, what I would say on this is, I might want to use that other technique here. This is more y equals mx plus b, isn't it? If I think of this as being y equals mx plus b, the m is negative 3. What's the b? Yeah, the b is not showing there, but I can think of the b as 0. So let's use that technique. Remember using that. So now I can graph off of that. The b is the y-intercept, right? And so this is 0 is my y-intercept. The slope is negative 3, which is negative 3 over 1, which I can say is my rise to run. The rise negative 3, run of 1 from there, so rise negative 3, down 3. Then run 1, that's a positive 1. So I'd run to the right. There you go. Now, before you draw your line in, you need to think dotted or solid. Which is it? It's going to be dotted in this case. Why? You don't have the equal to part. Yeah. If you don't have the equal to part, whether it's less than or greater than, you use a dotted line. That's what I'm going to use here. Okay? All right. What's left? Shading. Which is just really amounts to just checking one point. Now, why could I use 0, 0? Why not? It's on the line, yeah. When you check the shading, you want a point not on the line. 0, 0 happens to be on this line, so we can't use 0, 0. No, we have to use some other point not on the line, and that's totally up to you. You can move just one over. We could do 1, 0. We could do 1, 1 if that. Just some point not on the line. Let's go with 1, 1 since it goes pretty well with 0, 0, but since we can't use 0, 0, let's use 1, 1. Okay? All right. So yeah, check 1, 1. X is 1, Y is 1. So that'd be 1 is less than negative 3 times 1. 1 is less than negative 3. Is 1 less than negative 3? No, it isn't. So what does that tell me? I'd want to shade the side that doesn't have 1, 1 in it, right? So 1, 1's up here, so I go to the other side. There you go. Questions or concerns?